Okay, so today is November 24th, and you're here for Econ 249. You're looking at a flyer that was sent to me by one of your peers who's a part of Ascend, a student club on campus. And I put in the chat box the link to sign up for this free presentation. It's about careers in finance, and it's presenters from JP Morgan Chase and Morgan Stanley. It's free, but it is today, November 24th, from 6:30 p.m. to 8 p.m., and you have to register in order to get the Zoom link. So there is the link in the chat box. Does anyone have any questions for me about this? Okay, so a couple of announcements. The first thing is a reminder to evaluate your courses. So I'm not sure if this evaluation link is open as yet. They told me that it will be open today, but some students told me that they don't seem to see it open as yet, so it might be tomorrow. But this is where you would go, qc.cuny.edu/evaluate. Nayang says it's not open yet. Okay, so maybe give it a day or so. And once you log in here, you will see a list of all the courses you're registered for this semester. I am encouraging course evaluations. So once you click on my course and you submit your evaluation, the next page will give you an option to let your instructor know. If you do that, you will get 1 extra credit point for this course. So I don't know what your other instructors are doing, but I'm going to give you an extra credit point if you submit it, and make sure you let me know that you submit it through that inform instructor box. So what I get is an automatic email saying that you've submitted it, and all the evaluations I get to read next semester, they're all anonymous, but at least I am able to give you that extra credit. Okay, so they are due December 14th. Just put it down somewhere as soon as it opens to submit this. Regarding your final exam is on December 17th. It's a Thursday. It's going to be around the same time of our class time, around 12:15. The exact time is on CUNY first, and when it gets closer to the date, I will send you details about the final exam. It's the same place as where you took exam 1 and exam 2, where you do the homework. We have about 3 more classes till the final exam. Our last class is on December 8th. So this would be the last chapter that we're doing now, which is chapter 12. We do not have class on Thursday this week because it's Thanksgiving. So just keep yourself updated on the homework. Chapter 12 homework, there's a lot of problems and exercises for you to complete. Okay. Any questions for me before we start lecture today? Okay, so moving on to this slide. So this is how the chapter is going to be taught. First, so today's class, today I will perform a z-test for the mean with sigma known. So in class today, you will learn how to do a hypothesis test using the z-table, and particularly when the population standard deviation is given to you. And we will do one-tail and two-tail tests. And then in the next class, we'll do a t-test for the mean with sigma unknown, and then a z-test. And I will show you 2 methods, the rejection method as well as the p-value method. And that's how this chapter is organized. So when you do your homework, make sure you follow the same thing. You won't be able to answer the homework questions that are asking about proportion if I haven't taught you about proportion yet. Okay, so I'm going to start with this slide first. So decide on the model to test the null hypothesis and parameter. So before you even begin your calculations, read the question carefully, think about this experiment that you're working on, and decide which model you're going to use. Are you going to use, first of all, are you going to do a hypothesis test? Or is it sufficient to do confidence interval? And towards the end of this chapter, I will show you how you can relate both the confidence interval and hypothesis test together into one example. Okay, so decide on the model. So meaning decide whether you're using a z-test or a t-test. And what's the parameter? So are you trying to find out something about the mean or about the proportion? Okay, so those are the two things you need to figure out. What's the model? Is it Z or T? And what's the parameter? Mean or proportion? Then check the conditions. Randomization condition. Are the items or people in your sample randomly selected? What about the 10% condition? Is your sample less than 10% of the population? What about independence? Were the items in the sample independent of each other? Or does one outcome rely on the other? What about your sample size? Is it large enough? If the conditions are not met, then either quit or redesign the study. So that means you need to stop the study, or you have to redesign, reorganize your sample, get more items into your sample, or make sure they are randomly selected, so you have to redesign the study. Otherwise, your analysis is going to be incorrect. And then name the model. For example, are you doing a z-test of hypothesis for population mean when your population standard deviation is known? Or are you doing a t-test of hypothesis for mean when sigma is unknown, just like your confidence interval, right? You use the t-table when sigma is unknown. Or are you doing a z-test of hypothesis for proportion? When you're dealing with proportion, you always use the z-table and do a z-test. So in today's class, this is what we're going to do. We're going to do a z-test of hypothesis for population mean when sigma is known. Okay, so this is a new slide. Again, clarifying, this is a hypothesis test. So reading the example says, based on historical information, the average lifespan in the US is 70 years. For several reasons, we think that the average lifespan has changed. Now, before I read further, let's go back and understand the first sentence. So, based on history, based on past historical data, we know that right now the average lifespan in the United States is 70 years. People live up to 70 years. Okay, so this is current information. This is how it's been. This is the value. So in other words, you're told that the population mean currently is this initial expected value. So I'm writing mu 0. This initial expected value is 70 years. This is the initial population mean. And now, for many, many reasons, we think that this average lifespan has changed. We think that people do not live up to 70 years. Now, the question doesn't say that we think that people live longer than 70 years or less than 70 years. The only thing we're told is that the average lifespan has changed. Now, suppose we take a sample of 81 and we find that the average for the sample is 72 years. So we assume that they took a sample of people, of 81 people, randomly selected, and they found that those 81 people died at a certain age, and they took the average age, and they found that X bar, the sample mean, is 72 years. Okay, so this is not something to guess. This is 100% accurate. These calculations, you take it and you can easily calculate it, right? So that information is given to you. X bar is 72 years and the sample size is 81. Okay, now the question says, based on this information, can we conclude that the average lifespan has changed? Assume population standard deviation is 8 and alpha is 0.05. So this question is not saying anything about confidence level, confidence interval. So it doesn't mean that you're going to do confidence interval estimation. The question is asking you about checking a process. Has something changed? Is something different? So it's asking you, can you conclude that the average lifespan has changed? If the question asks you to check something, that means you're going to do a hypothesis test. So that's your clue. And now, how do you know? So there's only two kinds of hypothesis tests. You can either do a hypothesis test for mean or a hypothesis test for proportion. How do you know this is mean? Because it's very specifically says average. So we know we're dealing with mean. There's nothing, no indication of percentage, nothing mentioned about proportion. Okay, so you're going to do a hypothesis test for mean. Now, do you know what the population standard deviation is? So here you're told in the question to assume that the value for sigma is 8. So you are given the population standard deviation. And you're also told to take alpha as 0.05. So does everyone understand that why we're doing a hypothesis test for population mean? So, okay, good. That's the main reason. I mean, that's the first thing you should do before you start calculating and doing your hypothesis test. Really understand the question. Because if you get that wrong, then everything else is going to be wrong. Okay, so in the last class, I mentioned that the hypothesis test is actually 7 steps. It's a 7-step methodology. So that's what we're going to do today. We're going to break this example up into 7 steps. When you're doing your homework, I encourage you to do the same thing, the same method I'm showing you here. Even if the question jumps and asks you something else first instead of the first step, you should still do your 7 steps and then answer the different parts of the question in your homework. Okay, so let's start with step 1. So step 1 is to state your null hypothesis. So if you recall, your null hypothesis is denoted by HO or H0. So HO states that, and now you have to state whether you're dealing with mean or proportion. And in our case, it's mean. So HO states that the population mean is equal to this initial expected value. So we expect it to be equal to 70 years, right? That's what we expect the current situation of the average lifespan, 70 years. Step 2. Step 2 is to state your alternative hypothesis. Okay, so the alternative hypothesis, H1, or in your homework it's written as HA, states that mu, and this is what the question is asking you to test. So it's asking you to test if the average lifespan has changed. So it didn't ask you to find out if it's greater than 70 years or if it's less than 70 years, but they want to know if it is not equal to 70 years. So now a couple of things happening here. First, in step 1, when you state your initial null hypothesis, you should always have an equal sign. Okay, so it's always an equality. Your step 2, Alternative hypothesis will never have an equal sign. Okay, the next thing is since this sign is not equal to, that means you're dealing with a two-tail test. So this is a two-tail test. If it had a different sign, and we'll do that in the next problem, you won't be dealing with a two-tail test. But for now, understand that in step 2, whenever you have a do not equal to sign, you're dealing with a two-tail test. Any questions so far? And everyone understands how we got 70 years, right? That's the current status quo. That's the existing condition, and we're testing to see whether that condition has changed. Step 3 is to state your level of significance, which is alpha. Now you're given alpha in the question. You're told that alpha is 0.05. You need to be given this value. There's no way that you would be able to find this out. You need to know how much error is tolerated. So they said 5% or alpha is 0.05. Now, because in step 2, you said that you're dealing with a two-tail test, you would divide alpha by 2. So, Detrick, can you give me the value for alpha divided by 2? Priscilla, you said 0.025. Okay, thank you. Ardu, you said the same. Okay, so we have step 3, which is our level of significance, and we divided it by 2 because it's a two-tail test. Next thing is step 4. Step 4 is your test statistic. Now, we've decided to use the z-table because we're dealing with mean and sigma is known. So my test statistic formula is z observed. The OBS at the bottom is z observed is equal to this formula. So this is a new formula. This is something you need to know that it goes with the test statistic value, square root of n times x bar minus mu 0 over sigma. So n, we were told they took 81 individuals, and x bar from that sample, the mean was 72 years, minus that initial expected value of 70 divided by the given population standard deviation. So Lubna, can you give me the value for this z observed test statistic? Purushottam, do you have it? Okay, everyone says 2.25. Thank you. 2.25. Got it, Lubna and Purushottam. Okay, 2.25. So that's my test statistic value. Step 5 is to draw my critical region. So there's two methods, right? I mentioned that I'm going to do two methods. One is the rejection method, one is the p-value method. So first, let's do the rejection method. So first, you're going to draw your critical region. So here I'm drawing my graph. And this is my center. Now, I first look at step 2. Step 2 is telling me that I am dealing with a two-tail test. So I'm going to mark my two tails. And those are my critical values. So I would have negative z, because remember we're dealing with the z table. And we have positive z. Okay, with confidence intervals, you always shaded the center. But with hypothesis tests, you're always going to shade the tails. Okay, you always shade the tails. So now we're doing a hypothesis test, so that means I shade the tails, and I know that I have two tails, so I'm shading the two tails. If this was confidence interval, I would have shaded the center because that's my area of confidence. Okay, my two tails are alpha divided by 2, which we found in step 3 to be 0.025. And then this is also alpha divided by 2, which is also 0.025. Okay, next step is to indicate on my graph what the critical region is. So I have to indicate where I would reject the null hypothesis and where I would not reject the null hypothesis. So if anything falls in this shaded region, my decision is to reject HO, reject the null hypothesis. And same thing on this side, if I have anything that falls in this shaded area, I would also decide to reject the null hypothesis. If anything falls in the unshaded region, then my decision is do not reject HO. So this is we're still on step 5. We're still drawing the critical region. Now, I don't know what my critical values are. I don't know what Z plus and minus Z, those values are. So I'm going to look up in my table. You can look it up in the table or you can use Excel, whatever you're comfortable with. Since the table is here on this screen, I'm going to use the table. Let's look at the negative Z value. It's just easier. So in order to look up the negative Z value, I need to use this area of 0.025 and look for it in the center of the table. When I look for 0.025 in the center of the table, it gives me the area from negative infinity up to negative Z. And that way I can find out what my corresponding Z value is. So looking in the middle of the table, I see it somewhere here. I don't know if you can see that, but that says 0.025. And what's that corresponding Z value? Can anyone see? Yes, Arzu, you're missing the 6, so I'm going to say negative 1.96. So this would automatically be positive 1.96, right? So I'll write here 1.96. Anyone not see that, not understand how we got those values? So you need to be able to either look up in the table or use Excel, use that formula that I gave you in the last chapter to get the Z critical values. Okay, we're still on step 5, drawing the critical region and identifying the critical values. Okay, so now for the rejection method. So the rejection method says, take your Z observed value. So our Z observed value is in step 4. So that 2.25, and figure out where does it fall in this critical region. So I'm going to exaggerate it a little bit. I'm going to say that that 2.25 value falls somewhere here, right? If this positive Z is 1.96, that's going to be my Z observed value. So that says OBS. And that value is 2.25. So now, since 2.25 falls in this shaded region, which is the reject HO region, my decision is going to be, what do you think? Yes, Armila, Priscilla, you're right. You're going to reject the null hypothesis. So Again, understand that once you draw your critical region and you identify your critical values, take your Z observed test statistic value and figure out where does it fall in your critical region. And since it falls in the shaded area, this rejection region, our decision, which is step 6, is to reject the null hypothesis. Now there's one more step, step 7, which is the conclusion, but I'm going to hold off on the conclusion till I show you method 2. Method 2 is the p-value method. So we check the p-value method also to be precise so that we make sure we're getting the same answer for both, for the rejection method and the p-value method. Now, why am I showing you both methods? Because for one thing, your homework tests you on both methods, so you need to know both. And the second thing is that in the future, if you take Econ 382, which is econometrics, it depends on which method your professor teaches you. And also, if you go out in the real world, some industries focus on the p-value more than the rejection method, and some do the other way around. So it really depends. So you need to learn both. Okay, any questions for me? Because when I switch over, you're not going to be able to see this stuff. Okay, so the next slide is the same thing really, but it just gives you the answers. So we said that HO states that it's equal to 70 years, not equal to 70 years, two-tailed, you divide it by 2. You found Z observed, we draw, and we got our critical values, plus or minus 1.96. And we did the rejection method, and we rejected the null hypothesis. Now, for method 2, which is the p-value method. Okay, so the first thing I'm going to do is draw my graph again. Okay, so when I draw my graph, we said that this is a two-tail test. So again, I'm going to identify my two tails and mark my critical values. So my critical value is negative Z and positive Z. So this is negative Z and this is positive Z. And the same thing as before, we found that Z is equal to 1.96. So I'm just going to indicate it here, 1.96. And this was negative 1.96. And then we indicated our alpha value. So alpha divided by 2 was equal to 0.025. And this is also alpha divided by 2, which is also 0. So this is an equal sign, 0.25. Okay, next step is, since we're doing the p-value method, I'm going to take my Z observed value of 2.25. So now my Z observed value of 2.25 might be around here, because if this is 1.96, then this would be 2.25. So I'm going to mark that. Z observed is equal to 2.25. And I'm going to actually put a line here. And I'm going to say, so I'll make this a different color, that this area to the right is my p-value. So you can see here that the p-value has nothing to do with the critical value of 1.96. The p-value has everything to do with your Z observed value. So with the p-value, we need to get the area of the p-value. So in order to get the area of the p-value, I need to look up my z observed value in the middle of the table. So if I look up z observed value of 2.25 in the middle of this table, so I'm going up to 2.2, which is here, and 5, which is here, what do you see as the area? Does anyone see that value? Yu Jiang, you say 0.9878. Okay, so that means 0.9878 is my area from negative infinity up to here. This is 0.9878. Because remember, we always get the area from negative infinity up to the z value. So if I looked up z equals 2.25, that area is 0.9878. But I need my p-value. So what is the p-value? Just this green area here. What's the p-value? Kevin, do you have an answer? Okay, Xiaoting, you say take 1 minus 0.9878. Okay, I agree. And then don't forget to divide it by 2 because we're doing a two-tail, which means that there's another one on this side. So divide it by 2. And when you divide it by 2, the answer is 0.0061. Okay, so that's how you get the p-value. So the p-value, now the next condition is once you get the p-value, if your p-value is less than alpha, then your decision is to reject the null hypothesis. So since you found the p-value to be 0.0061, and that's less than alpha of 0.05, your decision is to reject the null hypothesis. So you came up with the same decision compared to method 1, which is the rejection method. Now, just to remind you, the two different methods, the rejection method, you have the alpha value. You use the alpha value, that area, to look up the z critical values and then see where the z observed value falls in the rejection region or not. With your p-value method, you take the z observed value, look that up in the table, and get the p-value areas. If that p-value is less than your alpha value, then your decision is to reject the null hypothesis. Okay, so it's slightly different the way you look up on the tables, but you need to understand both. Any questions about how we got the p-value? So it's quite methodical. Your first step is to look up your z observed value in the table. And then if you've drawn your graph, you realize that that area that you get in the table is 1 minus that value, and then you have to divide it by 2 because you have a two-tail test. And the condition is if p-value is less than alpha, then you reject the null hypothesis. Okay, so before I go to the last step, which is step 7, let's go back to the steps that were indicated here. Okay, so I'm just going back to this so that you can see step 1 and 2. So we decided for both methods, method 1 and, oh, I'm sorry, I went to the wrong one. This one. We decided in both methods, method 1 and method 2, we decided to reject the null hypothesis. Okay, So if you reject the null hypothesis, that means that you're saying, and you go back to the null hypothesis, you're saying that you're rejecting this. This is not true. In fact, this is correct. So what is this? This is saying the average lifespan is not equal to 70 years. So step 7 is your conclusion. So for conclusion, you would state that the average lifespan has changed. So we conclude that the average lifespan has changed. It's not equal to 70 years. So that's what this last sentence is. Any questions for me? Okay, so make sure you really understand how to do these 7 steps. Because again, when you're doing your homework, you might be asked for test statistic first or level of significance first. Make sure you do the 7 steps on a separate sheet of paper and then go back and answer the questions. Okay, so right now what we just completed is a hypothesis test for population mean when sigma was given to you and you did a z-test, and it's a two-tail test. So now I'm going to change it a little bit and do a one-tail test. Any questions before we start that? Okay, so this is the next example. You're still doing a hypothesis test for population mean, sigma known. It's a z-test, so sigma is known. But now the question is saying, what if you were checking if the average lifespan is greater than 70 years? So based on historical information, the average lifespan in the US is 70 years. For several reasons, we think that the average lifespan has increased. So same question now, past history shows that people on average in the United States live till about 70 years, but now we think that information is incorrect. We think that it has increased. People live longer than 70 years. Suppose we take a sample of 81 people and we find that the average for the sample is 72 years. So still, these things haven't changed, right? The sample mean we find is 72 years. Our sample size is n, and that's 81. And we're still told that the initial expected value is 70 years. That's what the current condition is. But you're testing to see if the average lifespan has increased. So it's something more than 70 years. Assume the population standard deviation is 8, so you're given sigma and you're given alpha. Everybody understand the question? Okay. So moving on to the next slide. So step 1 is to state your null hypothesis. So step 1, HO states that the average lifespan is equal to that initial expected average lifespan, which is equal to 70 years. Step 2, the alternative hypothesis H1 or HA states that mu is greater than 70 years, because now we're checking to see if something has increased. So your step 2 is based on what the question is asking you to test, greater than. Now remember, you would never have an equality, an equal sign in step 2, right? You would always have it in step 1. Now I can leave step 1 as it is, or I can go back and change this to make it exactly the opposite of step 2. So I could make it less than or equal to. which is the same thing. Okay, so currently we're saying that the average lifespan is 70 years or less, which is the exact opposite as greater than. Now I also have to indicate in step 2 whether or not I'm dealing with a two-tail or one-tail test. So now in this case, it's a one-tail test because the sign is greater than. If your sign is less than, it would also be a one-tail test. Everyone got that? Okay. Step 3 is to state your level of significance. Now this is given to you in the question. They said that take alpha is equal to 0.05. Now you would not divide alpha by 2 because you're dealing with a one-tail test. Okay, so alpha is equal to 0.05. Step 4 is state your test statistic. The test statistic is Z because you're using a Z table, and it's Z observed. So that's the same formula that I gave you from before. Nothing really has changed. N is 81, X bar is 72, mu 0 is 70, sigma is 8. So we found out that Z observed is 2.25. That does not change, right? That stays the same. Step 5 is to draw your critical region. Okay, so here you have the graph. It's already drawn for you. Remember, you're doing one tail. Now, how do you know if you have to shade the tail to the right or make a tail to the left? So that's when you look at your step 2, your alternative hypothesis. Since the sign is greater than, that's when you decide that you're going to shade to the right. So you shade only to the right one tail. If your sign said less than, so for example, if they said, we think that the average lifespan has decreased, it's less than 70 years, then you would flip this and you would have only one tail shaded to the left. Okay. So still on step 5, critical region, you're going to indicate your critical value here. Now it would only be a plus Z. You don't have a negative Z. And you know that this tail has an area of 0.05, that alpha. So that's your alpha value, right, of 0.05. So using that information, you can look up the Z table. So for me to get this positive Z value, what should I do? How should I get this positive Z value? If that shaded area is 0.05, then this unshaded area is 1 minus 0.05, and then what would this unshaded area be for me to look up in the table? So 1 minus 0.05 is what value, Hiba? Mirza? So what is 1 minus 0.05? Thank you, 0.95. Okay, so that's what we're going to look up in the table in order to get the critical value. So looking up in the middle, because this is what I'm looking up, right? From negative infinity up to there, I found out is 0.95, and it's somewhere around here. It could be one of these two numbers. So that means Z is equal to 1.64 or 1.65. So either one you choose is fine. I think your homework might sometimes choose 1.645, which is the average of the two. So in this case, I'm choosing Z equals 1.64. Okay, so that's how we got Z equals 1.64. So now we have our critical value. We drew our graph, we indicated one tail, That one tail has an area of alpha. So we were able to use that value to find the critical value of Z. Now the next thing, still method 1, rejection method. Where does Z observed fall? So I'm first going to write here 1.64. Okay, so where does Z observed fall? So Z observed is 2.25. So I'm going to kind of indicate that it falls somewhere here. So this is my Z observed value. Of 2.25. And so what do you think the answer would be for step 6, my decision, using this rejection method? So you all say to reject the null hypothesis. Agree. So since Z observed of 2.25 falls in the rejection area and is greater than the critical value of 1.64, the decision is to reject the null hypothesis. So even though you can visually see this on your graph, make sure you're able to explain it. Okay, so just making that decision, you might have to explain why in your homework. Why did you decide to reject the null hypothesis? So I'm moving on to the next slide because it gives you all the answers in a neater way. So again, since 2.25 is greater than the Z critical value of 1.64, it falls in that rejection area. So your decision is to reject the null hypothesis. So this method I showed you is the rejection method. Now we're going to switch to the p-value method. Any questions for me? Okay, so continuing to the next slide. So method 2 is to check the p-value to make sure that we get the same answer. Okay, so here we draw the graph, and I'm going to indicate a few more things on the graph. So first we know that, let me start that over again. We know that this is our critical value, and the critical value is plus Z, and everything I shade to the right depends on step 2 because it said greater than. Okay, so I'm shading to the right. We found out that the critical value, since this entire purple shaded area is alpha, which was 0.05, that critical value was 1.64, right? This stays the same. Now the next step is to figure out your p-value. Okay, so you take your Z observed value. So the Z observed value, so I'm going to indicate here Z observed, which is your test statistic value, we found out to be 2.25. Okay, so this Z observed value, take that value and look up in the middle of the table. Not in the middle, but look up in the table. So take that 2.25 value. So 2.25 is here. And can anyone see what that says? 0.9845. Actually, yeah, I think I chose the wrong one. Yeah, thank you. It's 2.25. Sorry. It should be this one. 2.25 is 0.9878. Yep, thank you. So that's 0.9878. So that means the area from negative infinity up to here is 0.9878. Okay, so it means from here to here is 0.9878. So we need to get the p-value, which is 1 minus 0.9878. So I'm going to write it here. It's 1 minus 0.9878. Conrad, what do you get as an answer for this? Okay, Rad, you said 0.0122. Okay, so now p-value is equal to 0.0122. So remember, our condition is if the p-value is less than alpha, then you reject the null hypothesis. So since your p-value is 0.0122, which is less than alpha, right? Because alpha is 0.05, then yes, that's correct, Priscilla. Your decision is to reject the null hypothesis. And in fact, we got the same answer when we did the rejection method. So the p-value method and the rejection method should be the same. So again, it's not difficult, but you have to be very methodical in the way you do the analysis. If you try to do it quickly and skip ahead, you're going to make mistakes. So again, understand that the rejection method means that you take your alpha value and look up your critical value in the table and see where z observed falls in the critical region to make your decision. With the p-value method, you take the z observed value, look that up in the table, and figure out the p-value. Now remember, it's 1 minus that p-value. And either you divide it by 2 or not, depending on whether or not you're dealing with a two-tail or one-tail test. And then if p-value is less than alpha, you reject the null hypothesis. That's always a condition. Okay, and then finally, your conclusion. Now, in order to make that or state your conclusion, let's go back to your hypotheses, or I can write it here. Actually, let me go to the next slide because it's a lot neater. So the next slide has all the values written up, and I'm going to just write down here the two hypotheses. So the null hypothesis stated that mu is equal to 70, and your alternative hypothesis, H1, stated that mu is now greater than 70. That's what you were checking. And in both cases, both methods, you rejected the null hypothesis. So if you reject the null hypothesis, you're saying this is rejected and this is okay, which means that the average lifespan has increased. So this is how you would word your conclusion. There is enough evidence to conclude that the average lifespan is greater than 70 years. So we say that it has increased. It's greater than 70 years. Does anyone have any questions for me? Okay, so when you're doing your homework, follow this method. Remember, you can't do proportion yet because I haven't explained proportion as yet. You can only do hypothesis test for mean when sigma is given to you. Okay, so I'm going to end class here. A reminder to complete the course evaluation whenever that link opens. And if you're interested in the Ascend panelists this evening, let me know. I can forward you the flyer. And there is no class on Thursday. It's Thanksgiving, so enjoy Thanksgiving and be well.